All right, so like I said, the main thing you need to be able to do is convert between exponential and logarithmic and just do basic equation solving. So today we're going to start with the basic equations, and then the next day we have class, we'll do the ones that are more complicated. So when it's basic, you just have one exponential or you just have one logarithmic expression. Then what you're going to do first is isolate either the exponential or logarithmic expression, just using addition or subtraction or whatever you need. The second step is to convert the equation to the alternate form. So if it originally was exponential, you change it to log. If it originally was log, you change it to exponential. All right, and then you are going to solve for the variable if necessary, just using algebra. And we're actually not going to do step 4. We're going to leave these in exact form. You already know how to type it in your calculator, so I don't really want to waste time with that. So today we're going to do everything without a calculator. I think you're going to be fine. All right, so example 1 is all exponential equations. So we know it's an exponential equation because the x is an exponent. And before we had logarithms, there was no way to solve or to get that x down. So I know you guys can move that 2 over, no big deal. That's isolating the exponential expression. But if we didn't use logs, can you think of a way to get the x down?
Square root of x.
The x root? But then what would you do? If you how would you find the x root of 9? That's a creative way to think about it, but it just wouldn't lead you to the answer. There's not a way. You have to do logarithms. Logarithms is the only way we can get that x down. So what we'll do now is write it in logarithmic form. So we'll start with the word log. What is your base going to be? 4. What is your argument going to be? 9. And then a logarithm always equals the exponent. And if this is x is already by itself, we're done. That is the answer. X is log base 4 of 9. Now, if you wanted to know what that is, 4 to what power gives you 9? Obviously, it's not an exact power. You can know it's between 1 and 2 because 9 is between 4 and 16, but it's 1.584962501 if you're interested. So we could take that number and put it in for x, and it would give you 9. All right, that's it, pretty much. Let's look at B. All right, so for B, the first thing we want to do is isolate the exponential expression. So we would move that 5 over by subtracting it. All right, and then this whole thing is the exponential expression, and it's isolated. So we can go ahead and write our log form. So this time it's going to be log base 2 of 21 equals x plus 3. Now we're not quite done. We need to move that 3 over, so we would subtract it. Do you guys think we can subtract it from the 21 and get log base 2 of 18? You can't. Because to be able to subtract, they would need to be like terms, and this is log base 2 of 21, which is some ugly decimal. Now I am pretty much always, if there's something after my logarithm, I'll put the argument in parentheses just so you know you can't subtract that 3. And if you went to type this in the calculator, you would know to make sure you close those parentheses after the 21. All right, so let's look at C. We want to isolate the exponential expression. So e to the x is the exponential expression. So what would you guys do first? Yes. Okay. And then we would want to divide by -4. Now we are doing this without a calculator, so you would just reduce both of those by -2. All right, so we're ready to write it as a logarithm. So what kind of logarithm is this going to be? Right, so the natural log of 5/2 is equal to x. And that's it. It's solved for x. You're done. All right, so what questions do you guys have on the exponential equation? Right? Okay, let's look at some logarithmic equations. So we want to isolate the logarithmic expression, which is this whole thing right there. So we're just going to use the algebra rules that you guys have known for many, many years. We would just subtract that 4 and divide by 2. All right. And then once you get the logarithmic expression alone, we're going to write it in exponential form. So the base of the logarithm is the base of the exponential expression. What is our exponent? 3. So a logarithm always equals the exponent. So 3 to the third should equal x plus 3. We got lots of 3's in this problem. All right, I do need you to know what 3 to the third is without a calculator. Do you know? 27. So 3 times 3 times 3. And then when I subtract 3, I'm going to get that x is 24. All right, so I should be able to take 24, put it in here, do all the things, and end up with 10. All right, let's look at the next one. So I'm going to go ahead and subtract that 2. All right, then I'm going to write this in exponential form. So 5 squared is 2x minus 1. And then I have a few steps to do. 5 squared obviously is 25. And then I'm just going to solve this algebraically. Okay. So on this last one, what would you guys do first? Multiply by 5. So solve an equation. There's something in a denominator that you don't want there. You just multiply by it. All right. And then my logarithmic expression is isolated. So I'm going to write in exponential form. What is my base going to be? E to the 5th equals 2 minus x. All right, so I'm going to do two things at once. I'm going to move the x over here. I'm going to move the e to the 5th over there. And if you're doing this without a calculator, there's no way to figure out what e to the 5th is, because e is a irrational number that goes on forever and ever and ever. So we're just going to leave it like that. That's what exact form looks like. And if they happen to put something like this on the ACT, that is how they would leave the answer, because the ACT questions are all supposed to be able to be done without a calculator. Calculator definitely helps, but it's not needed to do all the problems. Okay, what questions do you guys have on solving these equations? Okay.